Hello friends, I am Shabnam Tadgar from BSc 4th semester. My combination is chemistry and mathematics. My topic is manufacture and use of urea, calcium ammonium nitrate, ammonium phosphate and superphosphate of lime mixed fertilizer NPK. First we discussing about manufacture of urea. Urea manufacturing involves reacting ammonia and carbon dioxide, water high pressure and temperature forming ammonium carbamide which then decompose to yield urea and water followed by concentration and granulation. Here a more detailed breakdown of the urea manufacturing process. Raw materials and initial reaction. There are two raw materials. First one ammonia, second one carbon dioxide. Ammonia and carbon dioxide, these are the primary raw materials for urea production. Second one is reaction. Ammonia and carbon dioxide react to form ammonia carbamide. 2NH2 plus CO2, it gives NH2COONH4. Next, decomposition. Ammonium carbamide then decomposes into urea and water. It uses NH2CONH2 plus H2O. It uses NH2COONH4. Discussing about urea manufacturing process. These are 6 steps involves. Step 1, ammonia production. Natural gas is fed into a reform where it is converted into hydrogen and carbon monoxide. The hydrogen is then reacted with the nitrogen in the Haber-Bosch process to produce ammonia. CH4 plus H2O, it gives CO plus 3H2O, and another reaction N2 plus 3H2, it gives 2NH3. Step 2, carbon dioxide source. Carbon dioxide is obtained from various sources such as a natural gas processing, ammonia production or as a byproduct of other industrial process. Step 3, urea synthesis. Ammonia, NH3 and carbon dioxide are fed into a reactor where they react to form urea and water through the following reaction. 2NH3 plus CO2, NH2 twice CO plus H2O. Step 4, urea purification. The resulting urea solution is purified through a series of processes including stripping, removing excess ammonia and carbon dioxide, recrystallization, separating urea from impurities. Third one is centrifugation, separating urea from impurities, solid urea from the mother liquid. Granulation. The purified urea is then converted into its final form, either pellets, small spherical plates or granules. Step 6, packaging and shipping. The final product is packed in bags or bulk containers for shipping to customers. Next we are discussing uses of urea. First one is agricultural uses. Fertilizer. Urea is a common nitrogen-rich fertilizer in agriculture, promoting plant growth and crop yield. Soil conditioner. Urea helps improve soil structure, increasing its water holding capacity and aeration. Next, second one is industrial uses. Resins and plastics, textile industry, paper industry. Third one is pharmaceutical and medical uses. Skincare. Urea is used in a skincare products helping to moisturize and soften skin. Wound healing. Urea is used to promote wound healing, reducing inflammation and promoting tissue repair. Pharmaceutical applications and nutrition, protein supplement, other uses, dye industry, explosive, cosmetics. Next we are discussing about manufacture of calcium ammonium nitrate. Calcium ammonium nitrate is a widely used nitrogen fertilizer. Here is an overview of its manufacturing process. Raw materials. These are 3 raw materials. First one is ammonia, second one is nitric acid, third one is limestone. Ammonia is produced through the Haber-Bosch process. Nitric acid produced through the Ostwald process. Limestone a natural occurring mineral. Next we are discussing manufacturing process. Step 1, nitric acid production. Nitric acid is produced through the Ostwald process which involves the oxidation of ammonium. The given reaction is 4NH3 plus 5O2, it gives 4NO plus 6H2O. 2NO plus O2, it gives 2NO2. 3NO2 plus H2O, it gives 2HNO3 plus NO. Ammonium nitrate production. Ammonium is reacted with the nitric acid to produce ammonium nitrate. NH3 plus HNO3, it gives NH4NO3. Step 3, calcium ammonium nitrate production. Limestone is reacted with the ammonium nitrate to produce calcium ammonium nitrate. CaCO3 plus 2NH4NH3, it gives CaNO3 twice plus 2NH3 plus CO2 plus H2O. Final product. The resulting calcium ammonium nitrate is a white crystalline solid with a nitrogen content of around 27-30%. It is highly soluble in water and is widely used as a nitrogen fertilizer in agriculture. Uses of calcium ammonium nitrate. Fertilizer in agriculture, explosives, water treatment, paper and textile manufacturing, pharmaceutical, de-icing agent, hydroponics nutrient solution. Calcium ammonium nitrate is used as a fertilizer in agriculture to promote plant growth. It is then utilized in the production of explosives. Calcium ammonium nitrate is applied in water treatment processes. Copper is also used in a paper manufacturing. Additionally, calcium ammonium nitrate is utilized in textile manufacturing. It is also employed in the pharmaceutical industry. Furthermore, calcium ammonium nitrate serves as a de-icing agent. Finally, calcium ammonium nitrate is used as a nutrient solution in hydroponics. Next, we are discussing about manufacture of ammonium phosphate. Raw materials. These are two raw materials. First one is phosphoric acid, second one is ammonia. Phosphoric acid is derived from phosphate rock or produced through the wet process. Ammonia is produced through the Haber-Bosch process or obtained from other source. Next we are discussing manufacturing process. Reaction. Phosphoric acid and ammonia are reacted in a controlled environment to produce ammonium phosphate. NH4 thrice PO4 plus 3H3PO4, it gives 3NH4H2PO4. This reaction is named monoammonium phosphate. Second reaction is 2NH4H2PO4 plus H3PO4, it gives NH4 thrice PO4 plus 3H2O. This reaction name is diammonium phosphate. Second one is crystallization. The reaction mixture is then cooled and allowed to crystallize. Centrifugation. The crystallized product is separated through centrifugation. Fourth one is drying. The separated product is dried to produce the final product. Fifth one is granulation. The dried product is then granulated to produce a uniform particle size. Next we are discussing uses of ammonium phosphate. First one is fertilizer, fire retardant, food industry, pharmaceutical, water treatment, textile industry, paper industry, explosive, cleaning agent, laboratory reagents. Next we are discussing about manufacture of superphosphate of lime. Raw materials, phosphate rock and sulfuric acid is a raw materials. Phosphate rock is a natural mineral containing phosphate. Sulfuric acid is a strong acid to react with the phosphate rock. Calcium oxide or calcium hydroxide used to neutralize excess acidity. Next we discuss manufacturing process. First one is grinding. Phosphate rock is ground into a fine powder. Reaction. The product powdered phosphate rock is mixed with the sulfuric acid in a reactor. This gives reaction Ca3PO4 twice plus 2H2SO4. It gives CaH2PO4 twice plus 2CaSO4. Third one is neutralization. Lime is added to neutralize excess acidity and produce calcium sulfate. It gives CaH2PO4 twice plus COO. This reaction gives Ca3PO4 twice plus H2O. Fourth one is filtration. The reaction mixture is filtered to separate the solid product from the liquid. Fifth one is washing. The solid product is washed to remove impurities. Sixth one is drying. The washed product is dried to produce the final product superphosphate of lime. Final product. Superphosphate of lime, also known as a single superphosphate, is a valuable fertilizer rich in phosphorus, essential for plant growth. Discussing uses of superphosphate of lime. First one is fertilizer. Superphosphate of lime is widely used as a fertilizer in agriculture to provide phosphorus to crops. Second one is soil conditioning. It helps to improve soil fertility and structure, increasing crop yields and plant growth. Third one is plant nutrition. It provides essential nutrition for plant growth including phosphorus, calcium and sulfur. Fourth one is crop development. It promotes healthy crop development including root growth, flower and fruit formation and overall plant health. Fifth one is soil pH correction. Superphosphate of lime helps to correct soil pH imbalance, making it suitable for a wide range of crops. Sixth one is organic farming. It is a natural, environmentally friendly fertilizer. Seventh one is horticulture to promote healthy plant growth and development in gardens and landscapes. Eighth one is agriculture research to study plant nutrition and soil science. Discussing about manufacture of mixed fertilizer NPK. Raw materials. There are four raw materials. First one is urea, second one is diammonium phosphate, third one is potassium chloride, fourth one is fillers. Urea is a nitrogen rich fertilizer. Diammonium phosphate is also rich fertilizer. Potassium chloride is also rich fertilizer. Fillers is a inert materials like dolomite, limestone or sand. Next we study manufacturing process. First one is weighing and mixing. Urea, diammonium phosphate and potassium chloride are weighed and mixed together in a specific ratio to achieve the desired NPK formulation. Second one is granulation. The mixture is then granulated to form uniform particles. Third one is drying. The granules are dried to remove excess moisture. Fourth one is screening. The dried granules are screened to separate them by size. Fifth one is coating. The granules may be coated with a thin layer of material to improve handling and storage. Sixth one is packaging. The final product is packed in bags or bulk containers for distribution. The final product is a uniform granule mixed fertilizer NPK that provides a balanced mix of nitrogen, phosphorus and potassium nutrients for plant growth. Next we are discussing last topic, uses of mixed fertilizer NPK. Mixed fertilizer NPK provides essential nutrients for plant growth and development. Second one is it improves soil fertility, structure and overall health. Third one is NPK fertilizer increases crop yields and promotes better quality. Fourth one is it promotes healthy development. Fifth one is mixed fertilizer NPK supports leaf growth, greening and overall plant vigor. Sixth one is enhanced fruit and flower formation. Seventh one is NPK fertilizer boost plant resistance to disease, reducing the need for pesticides. Eighth one is it helps correct soil pH imbalances, creating a favorable growing environment. This is all about manufacture and uses of urea, calcium ammonium nitrate, ammonium phosphate and superphosphate of lime, and manufacture and uses of mixed fertilizer NPK. Thank you.